Okay, so the next set of formulas that we're going to look at, the cofunction identities and odd-even identities, these are on your formula sheet, so you would never have to memorize these. If they wanted you to use this like next year or in an exam, they would give you the formulas. So if you just take a look at them, the cofunction is just if you're given pi over 2 minus theta, it just tells you what it would be equal to. And then odd even just tells you if there was a negative involved, like what would happen with it, where that negative would actually go. So these once again, do not have to memorize these, they would be given to you. So then looking on the next thing, so they want us to find if tangent theta, the tangent of pi over 2 minus theta equals negative 5.32, and they want us to find cotangent theta. Okay, so I'm going to go back to the formula, because we're going to be using that formula sheet. So if you look at your formula sheet, it tells you that tangent pi over 2 minus theta, which is what we have here, and it tells you that is equal to cotangent theta. So cotangent theta means that has to be also equal to negative 5.32, and that's what they asked us to find. So this is our answer. And that's all they wanted for that part. Alright, so the next one with these formulas, it says cosine theta is 0.34, and we want to find sine of theta minus pi over 2. Okay, so I'm going to do this one a little bit different. I'm going to start with my sine of theta minus pi over 2. Now I'm going to go back to the formulas. Once again, these formulas will be given to you. So if you notice, first thing, we're kind of looking at this top formula here, but this one says pi over 2 minus theta. So I'm going to rewrite this as sine. I'm just going to rewrite this in a different order. Negative pi over 2 plus theta. That's what it says right now. Okay, so I needed to say pi over 2 minus theta. So if I was to take out a negative inside that parentheses, so make this negative parentheses pi over 2, and that would make that minus theta. Okay, so it almost looks the same except for this extra negative that we have here. So I'm going to have to come down here and look at the odd-even identity. So it says if we have sine of a negative in the parentheses, that negative is actually just going to come out to the front. So that formula right there is telling me this negative, we can really just bring it out front. So this is the same thing as negative sine of pi over 2 minus theta. Okay, all because of that formula of the odd-even identity. So I'm going to keep this negative, and now looking at the formula, see it says sine of pi over 2 minus theta, that's equal to cosine theta. Okay, so all of these things were equivalent to each other. We're just writing them in a different way. Now, if we go back to the top, it tells us cosine theta is 0.34. Well, this is negative cosine theta, so we know this has to be equal to negative 0.34. And that would be our final answer for that part. Okay, so moving on, for the next part, the next couple problems, we're going to just be simplifying, and it wants us to simplify it to a basic trig function. So kind of like we were doing on the warm-up. And we're going to use any of the formulas that you're supposed to memorize, or we can use the formulas that would be on your formula sheet. And once again, that formula sheet is on Canvas, so you can find it there. So the first one, we have sine cubed x plus sine x cosine squared x. And it does give you a clue that you want to factor here. Okay, I won't always give you a clue, but it says we want to factor. So when it says factor, we need to think about GCF. So what is the greatest common factor that goes into both of these? So the greatest common factor would be sine x. So if I take out a sine x, so if we divide this first term by sine x, that would leave us with sine squared x, plus, if we divide the second term by sine x, that would just leave us with cosine squared x. Okay, so if you look, sine squared plus cosine squared, and if you want to look back at your Pythagorean identities, cosine squared plus sine squared is equal to 1. So this is really sine x times 1, which would just be sine x. So we simplify that to one basic trig function. Okay, so if we take a look at the next one. So for the next one we have secant x plus 1 times secant x minus 1 over sine squared x. It does give us a clue here. It says to multiply first and then simplify using identities. So we do want to do that. If you ever see anything that you can multiply out, you would want to do that first. So I'm going to multiply out this top part first. So this will give us secant squared x minus secant x plus secant x and then minus 1. That would be the numerator. Denominator, there's nothing to multiply. Okay, so we can cancel out the negative secant x and the secant x. And then, so we're going to have left in the numerator secant squared x minus 1 over sine squared x. Okay, so all we did was just multiply the numerator out and simplify things that cancel. So I want you to take a look back at your Pythagorean identities. So if you find one that has secant squared in it, okay, so just over to the side, we know that 1 plus tangent squared x is equal to secant squared x. Alright, I want to rewrite this so it's in this form I have here. So if I rewrite this, if I move that 1 over, this tells me tangent squared x is equal to secant squared x minus 1. So guys, a lot of time you'll use the Pythagorean identity, but you're going to have to rewrite it. So we know now secant squared x minus 1 is tangent squared x. And then we still have the same denominator here. Okay, so from here, this is back to problems like a warm-up. So we want to write everything in terms of either sine or cosine. So we know tangent is sine over cosine. So because it has a squared, you're going to write sine squared x over cosine squared x. And then we still have the same denominator. If you want to write this as over 1, you can do that, because what we have here is we have a fraction divided by a fraction. So we're going to do same change flip. So we're going to keep the top fraction the same. We're going to change the division to multiplication, and then we're going to flip the second fraction. So now we have sine squared in the numerator and the denominator, so those can cancel. And we're going to have 1 over cosine squared x. Well, we know 1 over cosine is secant, so that's going to give us a final answer of secant squared x. So we have reduced that to one trig function, even though it's squared, that's fine. And that's what we're going to get for that. Okay. And then the last problem that we have for just simplifying. Find it. So we have cosine x over 1 minus sine x minus sine x over cosine x. So the clue here is to simplify by combining fractions. So if you ever have two fractions where you can make them have common denominators, that's what you want to do. So guys, just like when we did rational functions, I don't like working with subtraction, so I'm going to change this to addition and make this negative. Don't have to worry about that. And then we want to make them have the same denominators. So this denominator is missing cosine x. So put it in the denominator and the numerator. This denominator is missing 1 minus sine x. Okay, just like if you were going to add two fractions together, we're going to have cosine times cosine, which is going to be cosine squared x, plus, this one we're going to have to distribute, so we're going to have negative sine x, and we're going to have negative sine x times negative sine x, which will be plus sine squared x. We are not going to multiply out the denominators, we're just going to write them as cosine x times 1 minus sine x. Okay, so this is where you have to be looking for your trig identities. So I'm going to go back to my trig identities. If you look at that top one, cosine squared plus sine squared is equal to 1. So we can rewrite that cosine squared plus sine squared gives us 1, but we got to keep the minus sine x. And I haven't changed anything with the denominator. But then look what can happen here. The 1 minus sine x's can cancel. So you're left with 1 in the numerator over cosine x. And we know that 1 over cosine is secant. So secant x is what it's going to simplify down.